Today we are going to discuss classification algorithms based on decision tree. At the end of this session, the student will be able to demonstrate various classification algorithms based on decision trees and compare between them. A tree is basically generated and a set of rules are derived from the given data set. The records which are available for developing classification methods are divided into two disjoint subsets, a training set and a testing set. The training set is used to prepare the model and the testing set is used for validating our particular model. The attributes of records are categorized into two types. One, which are in terms of numbers, numerical attributes, and the other are categorical attributes whose domain is not numerical in nature. Now, when we go for decision trees, we see that an inner node represents an attribute, an edge represents a test on the attribute of the father node, and a leaf represents one of the classes. For generating a decision tree, we use the data which is called as the training data. And we basically use a top-down approach of going from a node which is at a highest level to the leaves. Here is an example of a decision tree where we take a training data set, and this data set has 5 attributes. The attribute class is the class label, and the attribute temperature and humidity are numerical attributes. The other attributes are categorical, that is, they cannot be ordered. We need to find out the set of rules. What values of outlook, temperature, humidity, and windy determine whether or not to play golf from the training set. So we draw the particular tree, and we have 5 leaf nodes in this particular tree. In a decision tree, each leaf node represents a rule, and therefore we could get rules of this type. We have now derived 5 rules. The 5th rule is, if it is rainy and windy, then don't play. These are based on the decision tree that we have created. Now let us pause and think for a while on how decision trees are going to help to do a classification of the particular data which is in the form of our data set. For classification, we traverse the tree from the root node to the leaf node. The record enters the tree at the root node. At the root, a test is applied to determine which child node the record will encounter next. This process is repeated until the record arrives at the leaf node. All these records then end up at the given leaf node are classified in a same way. Thus, we are doing a classification where there is a unique path from the root right up to the leaf, and the path is a rule which is used to classify the records. For an unknown record now, which is selected from the test data, we perform a classification as follows. Let us assume for the record that we know the value of the first 4 attributes, but we do not know the value of the class attribute. For example, outlook is equal to rainy, temperature is 70, humidity 65, and windy is true. We start from the root node to check the value of the attribute associated at the root node. The attribute is at the splitting attribute of this node. For a decision tree, every node there is an attribute associated with the node called as a splitting attribute, where we split in different directions. In our example, outlook is the splitting attribute at the root. Now, the accuracy of such a classifier is determined by the percentage of the test data set that is correctly classified. For example, if you look at the rule 1, then there are two records of at least the test data set satisfying outlook to be sunny and humidity to be less than 75. And only one of these is correctly classified as going to play, which tells us yes there. Okay. Thus, the accuracy of the rule is 0.5. Similarly, the accuracy of rule 2 is also 0.5. The accuracy of the rule 3 will be 0.66. This figure gives a decision tree for the training data, and we see that the splitting attribute is the pin code that we are seeing right on top. And at the root level, we have now 9 records. The associated splitting criteria is the pin code, and as a result, we split the record into 2 subsets. We keep record 1, 2, 4, and 8 and 9 to the left child node and the remaining to the right child node. The process is repeated at every node that we are encountering. What are the advantages of using a decision tree classification? A decision tree construction process is concerned with identifying now the splitting attribute. And what is the major strength? The decision tree is able to generate understandable rules. They are able to handle more numerical and categorical attributes, and they provide a clear indication of which field are the most important for prediction or classification. But the weakness is the process of growing a decision tree is very computationally expensive, because at each node there is a splitting and it is examined before the best split can be found. And some decision trees can only deal with binary value target classes. The ID3 or the iterative dichromatizer developed by Quillam, where each node corresponds to a splitting attribute, has become very popular while using decision trees. And each arc is a possible value of that attribute. Here we calculate the quantity after splitting. At each node, the splitting attribute is selected to be the most informative. So it is the splitting attribute which is most informative, and we find out an entropy, which is the measure how informative it is, and we go then for applying an information gain to determine the goodness of the split. Here we have a training data set which has attributes in it, and we have values which are given to attributes which contribute to developing of a particular rule. So we have two distinct classes here. So M is equal to 2, which is yes, a computer is bought, or no, a computer is not bought, depending on different attributes that have been encountered. We could extract the classification rules by building our particular decision tree, and we represent the knowledge in the form of if-then rules here. Okay, and the leaf node holds the class prediction finally, and rules are easier to understand by human beings. The solution rules look like this. Okay, they are in the if-then form, and the algorithm for decision tree induction, which is the next method, is a greedy algorithm. Here the tree is constructed in the top-down fashion using divide and conquer approach. And at the start, training samples are at the root, okay? And we go on to analyze the attributes and categorical references to them, and we then use all these test attributes which are selected on the basis of heuristics and statistical measures. Okay, we apply a condition for stopping this particular partition, and that might be by majority voting, or we have encountered all the samples for the given node which belong to the same class, or there are no samples which are left. The attribute selection measure of information gain is done by using ID3 algorithm or C4.5 algorithm, which is supported by decision trees. Here we select the attribute of the highest information gain to be split, and this contains tuples. Okay, based upon these particular tuples and the information measures, we are doing some calculation. Okay, and we are finding the entropy and the information gain, and then selecting those particular tuples to be put into a particular class. So we could calculate entropy in this particular fashion because it measures the homogeneity of the set of samples to be put in a particular class. It gives information content. It is when we consider a set of samples, you would have these samples to be put into classes. Here we consider two classes, and we consider the probability, okay, of the instances of the classes to be capital P and n instances of the class to be capital N. Okay, so the total number of instances we have is small p plus small n, which is t. And we are going to do all calculation based on probability. The formula is given for entropy here, and we calculate the entropy for p to be 9 and n to be 5 to be 0.940. Similarly, we are going for entropy where all the particular items, data items, are in the first class and no data item is in the second class. Okay, so we have 14 items in first class and no items in second class. Okay, and we find the entropy to be 0 here. When we are taking equal distribution, then entropy becomes 1. The attribute selection can be done with the information on the gain computation. Okay, so since the age has the highest information, the gain among attributes, it is selected as the test attribute. Okay, here we are having everything represented in our particular data set. Okay, and we calculate the gain. The gain or the similarity, okay, for the income, student and credits are calculated on the right hand side. We have a table for the employees, and we let the status be a class attribute. Now we use the ID3 algorithm to construct a decision tree, and we get this decision tree which is constructed. Okay, we calculate the entropy at the various levels. Okay, and the other attribute selection that we are going to go for is depending upon the relationships, the attributes. Okay, so we are going to have a Gini index value, okay, which is done by the IBM intelligent miner, where all attributes are assumed continuous valued here. Then we assume there exist several possible split values for each attribute. Okay, not only at a particular node. Then many other tools such as that of clustering can get it possible to split these particular values, and it can be modified for categorical attributes. So the Gini index is calculated by this particular formula, and we see that the attribute provides the smallest Gini split is chosen to split the node finally. So we get a splitting of these particular attributes, and here we have a classification which is done, which looks very impressive. For our references, we have used the textbooks recommended to you along with some information from a tutorial which I have selected from the net. Thank you.